We see it every single day. That bright light in the sky that gives us warmth and, separates day from night. But what if I told you the sun is so much more than that? That it's literally the ultimate power source behind, well, almost everything you do. It kind of sounds like a riddle, right? I mean, think about it for a second. What connects the phone in your pocket, the wind that's blowing outside, and maybe even the food you ate for lunch? They seem totally unrelated, but they're not. They all trace their origins back to one single powerful source. Here's the thing. Almost all the energy we use, I mean all of it, from the ancient power locked away in coal to the energy spinning a modern wind turbine, it all comes from the exact same place. And you know what? That place isn't even on Earth. So, we're talking about the sun, our ultimate power plant. Let's really dig in and connect the dots here. How does this star, all the way out there, 93 million miles away, how does it act as the engine for, well, everything? Okay, so the connection, it all comes down to one thing: radiation. Solar energy travels all that way to Earth, and when it gets here, it heats up our atmosphere, but not evenly. Some spots get hotter than others. And that difference in temperature, that's what makes the air move. That's what we call wind. And that's not all. That same solar energy is what fuels photosynthesis in plants, the process that gives us our food. And over millions and millions of years, those same plants get compressed and become the fossil fuels that are powered our world. So, yeah, it's pretty clear that most of our energy is solar powered, one way or another. But there are a few exceptions, and they're pretty cool. You've got geothermal energy, which is basically tapping into the Earth's own heat. Then there's nuclear energy, which comes from splitting atoms right here on the ground. And tidal power, that's all about the moon's gravity. But almost everything else, from the coal deep in a mine to the solar panel on your neighbor's roof, yep, you can trace its power right back to the sun. All right, so we've established the sun is our ultimate powerhouse. But how? How does it actually work? What's the engine humming away inside that star that lets it pump out such an insane amount of energy every single second? Well, the secret has a name: nuclear fusion. It's basically the universe's ultimate energy recipe. Now, you've probably heard of nuclear fission. That's where we split big atoms apart. Fusion is the exact opposite. It takes really light atoms and smashes them together. And when they fuse, a tiny, tiny bit of their mass just disappears. And it's converted into a spectacular amount of energy. That's Einstein's famous E equals mc squared in action, right there. So, what's the sun's secret recipe for fusion? Well, first, you need crushing pressure and intense heat. I'm talking conditions in its core that we can barely even wrap our heads around. This environment is so extreme that it takes hydrogen atoms, which normally want nothing to do with each other, they actively repel, and it forces them to slam together and fuse, creating helium. And the final step? The result of all that fusing is a massive, incredible release of light and heat. And that's the energy that travels all the way across the solar system to power our world. So, okay, when you understand how the sun creates this incredibly clean and powerful energy, it leads to a really big question, right? Can we do it too? Is it actually possible to replicate that cosmic engine right here on Earth? And that's a fantastic question. I mean, think about it. The sun has been doing this for billions of years. It produces all this energy with zero carbon emissions, no long lived radioactive waste. It is the absolute dream of clean energy. So, what's stopping us? Why haven't we built our own miniature suns yet? The answer is we're trying. And I want to be clear, this isn't science fiction anymore. This is one of the biggest, most ambitious scientific challenges humanity has ever taken on. I mean, trying to create and then contain temperatures that are actually hotter than the core of the sun, it's just unbelievably difficult. But the potential payoff? It's almost unimaginable. And this isn't just happening in some single hidden lab somewhere. No, this is a massive, global effort. We're talking scientists and engineers all over the world working together on these gigantic projects. They're trying to figure out how to start a fusion reaction, how to hold on to it, and, this is the key part, how to get more energy out than they put in. Because the goal here isn't just a cool science experiment. The ultimate goal is a practical, safe source of electricity for the entire planet. There's actually a common saying among scientists who work on fusion, and it just perfectly captures the insane ambition of this whole thing. They say, we are trying to build a star on Earth. And when you think about it, they're not just trying to build a new kind of power plant. They're trying to fundamentally change our entire relationship with energy by using the same process that powers the entire universe. It is quite literally an attempt to build a star right here on Earth. So that leaves us with a pretty big thought to chew on. For all of human history, our progress has been shaped and honestly limited by how much energy we could get our hands on. It's always been scarce. So, what happens if that fundamental rule of our world just changes? If they actually succeed at this, what does our world even look like when clean, safe energy isn't just available, but nearly limitless? That's a future that's really worth thinking about.